The BSA is for sale. Now we will see what work was done inside the chain case. Firstly, everything is thoroughly cleaned. In the chain case, the clutch plates and the primary chain had recently been replaced. So now the clutch hub gets replaced also. The primary drive sprockets were aligned by using shims behind the front sprocket. The clutch cable adjuster is slackened right off. And the clutch mechanism was adjusted correctly. Then the clutch cable slack is taken up. And a 3-phase high output alternator has been fitted. Then the 3 slotted brass nuts are used to true up the pressure plate. It has to be made to run as true as possible. Perfect. And the outer cover is fitted later. Now we'll look at what was done inside the crankcase. The crankshaft was cleaned up, big ends and timing side main journals ground, and the end float is then set by a shim stack. So shims are added to the carrier and the crankcase is then assembled with the crankshaft. The end float is then measured. Here it is showing 5 thou or 5/1000th of an inch. The correct end float is from 1 to 3 thou. So dismantle the crankcase, install another 3 thou shim, reassemble and measure again. Success. This is measuring 2 thou or 2/1000th of an inch, right in the middle of the specifications. Perfection. The engine is now equipped with a pair of new MAP steel connecting rods, and they are a very well made component. You will notice the connecting rods and other engine parts being clamped in a vise. It has specially made soft aluminium jaws so no damage is done to components. Each bolt is measured and its length recorded. On assembly, each bolt is smeared with a special grease to control friction as it is tightened. The big end bearing shells are fitted to the conrod and the bolts tightened to the correct specification. And the diameter across the bearing is measured very accurately. Here a 1.5 inch internal micrometer is being used. The freshly ground big end journal on the crankshaft is measured and its diameter is subtracted from the bearing diameter in the conrod to give the oil clearance. In this engine, all the clearances are perfect, right on specification. Now the conrods are assembled onto the crankshaft. First we will tension the drive side. Note the roller bearing. I've got this one torqued to the right stretch. The bolt is stretched and it had to go up to 34 on the micrometer there. It's exactly it's exactly the right place. We've got the bolts stretched correctly. Perfect. Now this conrod bolt has not had any tension put on it at all yet, no torque, so that is its free length, 47.16 mil. Now I'll show you how much you have to turn the spanner, the socket, to get the bolt to stretch. So we'll go about that much, that'll go close. So now we were on 16, now we're on 23. We've got to go a bit more yet. We've got to go to 29. So we've got to give it a bit more yet. So we'll go that much. And the number we're looking for on here is 29. So it's 26. Go a bit more. We're looking for 29. Look at that. That shows you don't have to turn the bolts that far to get 5.5 thou stretch. Now, I'll just explain to you, I've got 30 hands, a little dobs of grease here. That's from the special grease that you have to use on these bolts as you're talking. They're supplied by MAP, the grease. It gets everywhere. It's a molybdenum type grease. It gets everywhere. I'll clean my micrometers up when I'm finished. But that one is exactly where we want it. Now I'll just give the final little tweak to the other nut over here. It's got to have a bit more yet. New Hepalite pistons and rings in perfectly bored and honed cylinders. Then the head was fitted with new valves and springs. The seats cut. A new Hepalite cast iron oil pump is fitted. The red arrow shows its position just below the timing pinions. Now, you can see that the timing marks on the crankshaft pinion and the intermediate gear are lined up. Now we'll go to the other side of the intermediate gear and I'll turn the engine forward a little bit, just go forward a little bit, right. And there the two marks are lined up, so that is the cam timing or valve timing for this old BSA are correct. Now to test the cam timing. So we're at top dead centre on this cylinder with both valves have been set to 15 thousandths of an inch, which is 0.38 millimeters clearance for the exhaust and the inlet. I can feel that clearance quite easily. Now I'm going to start rotating the engine forward in its direction of rotation, and I'm going to keep feeling that clearance at the rocker. So here we go, 20, 30. We've still got clearance, still got clearance, still got clearance. That's 90 degrees after top dead center, you know, which is about halfway down the bore. And here I can feel the clearance is decreasing very rapidly. We've got hardly any clearance there, hardly a little tiny bit of clearance there, little bit of clearance there. There, clearance has stopped, and it's taking some force to move that rocker sideways. That is the point where the valve just starts to open. Now look at what the degree wheel says. 78 degrees before bottom dead center. This proves that the camshaft is still as good as new. All the other valves showed the correct timing using the original BSA camshaft. It will, therefore, give good performance. And in fact, this BSA really has some grunt. This has only been a small sample of some of the work done on the BSA. There was much, much more. So here is a quick slideshow of some of the other areas repaired, tweaked, straightened, fixed up. And now the BSA is for sale. And if you are interested in it, please contact me and I'll direct you to the owner. Thanks for watching my videos, and please don't hesitate to comment or even subscribe. There are other videos in the works for you. Cheers.